All right, so here we go, guys. This is going to be CBA 8. Here's the CBA 8 review. Um, One of the things I noticed real quick, it says which table shows the values that represent the following relationship between A and B, but our variables are actually Q and P. So, I know I had you guys do this before, but for those of you who are just now watching it or whatever, um, I'm just fixing that, right? So that we actually have matching variables. Now, usually, this is usually my x value. Well, not usually. This is my x value. This is my y value, right? But usually, your y value is an outcome of whatever happens with your x, right? So here they're reversed. So what I'm going to do is I'm actually going to solve for p and then rewrite my equation, okay? So let's go ahead and do that. I'm going to do plus 11.1 plus 11.1. And now I'm going to rewrite it starting with my p, or my dependent variable. So now I have q plus 11.1. And so now it's just a matter of using some very simple deductive reasoning. Okay, if you know you're going to be adding to the value of your q, then if I added something to 20, the number would not get smaller. So I'm going to get rid of a. B, same issue. D, same issue. So without even doing any real work, by a process of elimination, we know C is going to be our answer. But now let's actually do that work, okay? We're going to plug in these values. The value for P is 31.1. 31.1. And we have that equal to the value of Q, which is 20, plus the 11.1. So now we'll add that and verify it. 20 wholes as a decimal looks like that. We'll add our 11.1. We'll get 0, 1, decimal, 1, 3. And we can verify this through our identity property. Oh, sorry. That 31.1 or 31.10 here is equal to 31.1 or 31.10, right? So that's how we verify this is our correct answer. Okay, number 2. Here we go. It says Amy works at the local bakery, or local country store rather, and she earns $92 for 8 hours of work. If she continues to work at the same rate, which table shows the relationship between the amount of time she works and the amount of money she earns? So right here it says she earns $92 for 8 hours of work. Okay, perfect. That works for me. What I can do is that if she makes this amount of money for her 8 hours of work, then I can just divide 92 by 8 to figure out how much money she is actually making per hour, so that I can see which one of these tables identify that relationship. So I know 8 goes into 9 once. Bring down the 2. Difference between 12 and 8 is going to be 4. 8 cannot fit into 4, so we add a decimal and a 0, and we bring that 0 down. 8 can fit inside of 40 5 times. So we know now it's going to be a multiplicative relationship, and we know that it's going to be times 11 and a half. Okay, cool. So this is important. This is our rule, right? It's times 11 and a half. All right, cool, awesome. So let's just see if we can find that same relationship with our first table. I'm going to get the value of my y, right? I'm going to get the value of my y and divide it by the value of my x, okay? So let's do that. I guess we'll do that. We can do that here. That's fine. 115 divided by 10. 10 fits into 11 once. That's going to give you 10. 11 minus 10 is 1. You bring down the 5. 10 fits into 15 once. The difference between 15 and 10 is 5. 10 cannot fit into 5, so you add a decimal up top and a 0 underneath, and you bring that decimal down. 10 can fit into 50 5 times. Bing, bing, bing. We have the same matching rule, so I know my answer is going to be F. Okay? So that's pretty simple. You can see here, this one's pretty close, but this one is increased by 10. Um, yeah, that one just kind of doesn't make any sense. So I would have gotten rid of this one too, pretty immediately. But that's generally how we're going to find what we need. Okay, they told us something. This is our dependent variable, our y. This is our independent variable, the hours. The hours are going to stay the same. Sorry about that. The hours are going to stay the same. But depending on how much she gets paid every hour, our rule, her dependent variable, the y, right? How much money she makes, her total amount of money really depends on how many hours of work she works. So that's why I was able to divide the 92 by the 8. We found our rule. This rule matches. We're good to go. All right, next one. Okay, here we go. So this one takes a little bit of prep. Okay. Well, this one's a little bit of work, which is fine. Cool, let's do it. So, first things first, okay? We want to identify which is our appropriate quadrant. So we know we have quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now, another really good identifier is understanding which quadrants represent which values, whether they're positive or they're negative, right? So for quadrant 1, you're going to have your x and your y values are going to be positive. For quadrant 2, your x and your y value, your x is going to be negative, but your y value will be positive. For quadrant 3, they're actually both going to be negative, both your x and your y values. And then in quadrant 4, your x value will be positive, but your y value will be negative, okay? And you want to think of these as your number lines. Here's your origin point, 0, 0. So if you're moving to the right and you're moving up, right, positive, positive. If you're moving to the left and you're moving up, you're moving negative and then up, okay? For 3, you're moving negative and then down. And then for quadrant 4, positive and then down, okay? Also, please know that that middle right there is going to be considered your origin or your origin point, and the coordinates for that is 0, 0. Okay, so a little bit of setup, but we did it. Let's keep going. Now it says which ordered pair does not appear to be represented by one of the points, okay? So first things first is we have to look at our answer choice A. We have an improper fraction, so we have to turn that into a mixed number, okay? So 5 goes on the inside, 2 goes on the outside. 2 goes into 5 twice. That's going to give you 4. 5 minus 4 is 1. 2 cannot fit into 1, so you have a decimal on top and a 0 underneath. You pull that 0 down. 2 fits into 10, 2.5 times. So here we have 2.5 and 2, and then I'm going to label each value. All right. So same coordinates, but in order to actually find it on the graph, it makes more sense to find it this way. So let's see if this dot is plotted here. So x will start at the origin point. We'll move 2.5, 1, 2.5, and then up 2, 1, 2. So this dot is plotted here. We know A appears. We're looking for what does not appear. So because A is there, I just can't choose it. And we'll do the same thing for B, okay? We'll do 7 divided by 2. 2 goes into 7 3 times. That's going to be 6. That's going to be 1. 2 can't fit into 1, so you add a decimal on top and a 0 underneath. You pull that 0 down. 2 goes into 10 5 times, and then you rewrite your ordered pair. So now I have 3.5, comma, -3, and you label sorry, your x and y values. So starting at the origin point, I'm going to move 1, 2, 3.5, and move down 1, 2, 3. So this dot appears, therefore I can't choose it. Remember, we're looking for what does not appear. Okay, we'll do the same thing. For C, I have 3 divided by 2. 2 goes into 3 once. That's going to give you 2. That's a 1. Can't fit in a 1. Decimal, 0. Bring it down. You have 1.5. So now our new coordinates here are -3 and 1.5. So here we go. -3, so we're moving 1, 2, 3 to the left, and then positive 1.5, 1.5. Well, there's nothing here, so this is going to be our answer right there. Okay, let's keep going. Number 4. All right, which real world problem cannot be represented by the inequality 14 times x is greater than or equal to 196? So we're looking for the wrong answer here. And we're going to build these as we look for that wrong answer. Okay, Selma is selling a box of candies for $14 each. $14 each is very important. That tells me that there's multiplication taking place. She wants to make at least, that's also going to be important, $196 for selling X boxes. Okay, we don't know how many boxes she's going to sell, but she's selling them at $14 a pop. So that represents my multiplication. At least, that means equal to or greater than or equal to. That means she wants to make $196 or more. And so there we go. Well, these two match. Therefore, I cannot choose F. Let's keep going. In a test, each correct answer is worth 14 points. Okay, that already tells me that I have 14x because I'm multiplying. Jenny had X correct questions. Her total score was not less than 196 points. Not less than means it could have been greater than, or again, equal to 196. That matches, therefore we cannot choose that answer. Here, Maria earns $14 per hour. Perfect. 14 times something. She wants to earn 196 or more. 196 or more after working X hours. Bam, there's our X. 196 or more. That matches our equation, or inequality rather, above. Therefore, we can't choose it. By process of elimination, right? J is going to be our answer. But let's still build this inequality and figure out why. It says Lily will solve 14 science problems every day for X days. Okay, that's 14 times X days. I don't know how many days. She plans to solve at most. Ooh, at most. So that means that she is less than or equal to 196 at most. Interesting. Now, because these don't match, that's why J is our answer. Okay, let's keep going. For number 5, okay, this one's a good one. Sorry, I was drinking some coffee. So this one's a good one, especially with the X over the 11, okay? Remember, if we were to turn this into an actual like division, like if we were solving this, right? We would ask ourselves like, okay, if it's top in, bottom out, okay? If the X is on the inside and the 11's on the outside, who's sharing what, right? So let's see if the top in, right, bottom out. So let's think about this. Am I sharing 11 marbles with X people, or am I sharing X marbles with 11 people? So what we're dividing here is the X, right? So the X is being shared. And the reason why I bring that up is because we can look at our answer choices. Jessica shares 11 marbles with X classmates, but we're not sharing 11 marbles. We're sharing X marbles. So we can get rid of that one because it says 11 marbles with X classmates. What's another one right here? 11 marbles with X classmates, right? Sorry, those two answer choices are gone. Now, So now it has shares X marbles with 11, X marbles with 11, but here it says each classmate has at most 13 and at least 13. So if I'm building this, then I have X by 11. At most means less than or equal to 13. At least means greater than or equal to 13. Which one matches our inequality above? This one right here. So C becomes our answer, and that's why B is not our answer. Okay, let's keep going. Okay. Number 6. All right, cool. Ooh, excuse me. All right, number 6, let's do it. Which statement describes the relationship between x and y in these two equations? So firstly, this is the value of y is equal to 4 times the value of x, okay? So this one immediately we should identify as multiplicative, but we can just write it like that. Here, obviously we're adding, therefore this is going to be additive. Now, all we're doing is matching these definitions to our equations above. So in x is equal to 4 times, or in y is equal to 4 times x, they're saying the value of y is 4 more than the value of x. Well, if this is multiplication and this is saying 4 more, this is addition and this is multiplication. So immediately this is wrong. In both equations, they're saying in y is equal to 4 times x and in y is equal to x plus 4, the value of y is 4 more than the value of x. Well, if this one's multiplicative and this one's additive, how can they then be both additive? That doesn't make any sense. G is wrong. In y is equal to 4 times x and is y is equal to x plus 4, the value of y is 4 times the value of x. Well, it's the same issue with G. They can't both be multiplicative if we've already identified the fact that one is multiplicative and one is additive. So H is wrong. J by default is correct. Let's see why. Because the value of y equal to 4 times the value of x, that means y is 4 times the value of x. Exactly, because that's how we just read it. In y is equal to x plus 4, the value of y is 4 more than the value of x. That makes sense. Wouldn't plus 4 be 4 more? Exactly. So that's why J is our answer there. Okay, let's keep going. Okay, so for this one, okay, we're going to do something I did in class as well, right? So they're saying point Q is located on the coordinate grid at negative 9.73 and negative 3.32. In which quadrant is point Q located? So I'm just going to put this up for about 5 seconds. So which quadrant represents two negative values? All right. Quadrant 3 is the only quadrant that actually represents negative values, okay? So that's super duper important. Quadrant 1 is only positive, quadrant 3 is only negative. So that's a easier way to differentiate between some of the quadrants, okay? But that one should have been pretty simple. Let's move on to 8. Okay, perfect. 8 I like. So whenever you see a graph and they don't give you a table, just very simply and quickly build an XY value chart. Simple, right? Perfect. Now, they don't give us an origin point, which I'm like, about, but we should have one anyway. And they want to know what our dependent quantities are, okay? Dependent quantities is always going to be your Y axis, okay? So, independent, dependent, okay? So now we're going to find a few of these values, right? Based on when our independent and dependent variables, when our X and Y values cross, to form that perpendicular line, okay? And that perpendicular line creates that corner of a square or a 90-degree angle. So let's do it. We have 2 and 7, 2, 7, 4, 14, 4, 14, 6, 21, 6, 21, 8, 28, 8, 28, 10, and 35. Okay? 10, 35. So again, our dependent is everything on our y-axis. So when they want to know what our dependent values are or quantities are, here we go. 7, 14, 21, 28, 35. Just like that. Okay, next page. Okay, we've done that one. Okay, so 9 is pretty similar. This time they're looking for the independent quantities, okay? So same thing. XY value chart, cool. Origin point real quick. And then we'll build our ordered pairs, okay? We have 1 and 6, 2 and 12, 3 and 18, 4 and 24, right? Remember, your X is always your independent, your Y is always your dependent. So they're wanting to know what the independent quantities are. That's all of your X values here. So your independent quantities are 1, 2, 3, and 4, literally just like that. All right, number 10. Number 10, okay? So we're looking at the relationship between X and Y. Remember that something has to happen between starting from X, something happens, and then our outcome is our Y. So if we look at this, we can see that our Y is getting smaller. So I know that I should be doing something, an operation where the value decreases, okay? And in this case, I'm just going to subtract. And we're going to see how that works. I'm going to take the value of my X, which is 41. I have a decimal, so I'm going to represent it with the rest of my decimal. And then I have a 29.5. And we're going to subtract and see what that difference becomes, okay? Can't take 5 from nothing, so I go next door and borrow. That becomes a 10. That's a 5. Drop the decimal. Can't take 9 from nothing, so again, I go next door and borrow. 9 minus 10 is 1. 3 minus 2 is 11. So I know that this represents an additive relationship of 11.5. So if I'm writing an equation, very simply put, I can say that the value of y is equal to the value of x plus 11.50. Right? Simple. Not hard. All right. Or wait, not plus, minus. Silly. Hold on. Hold on. My bad. Not plus, minus. Ooh, caught that one. I apologize for that, guys. Sorry. Subtract. Sorry. My bad. It's x, not plus, right? Our y values aren't increasing. They're actually decreasing. So I apologize for that. It's going to be minus 11.5. Minus 11.5. I apologize. Sorry about that. All right. Let's keep it going. Number 11. There we go. Okay, number 11. Let's go ahead and find the relationship here. So I'm noticing that the numbers are increasing kind of by a lot, okay? And so I don't know if this is going to be additive. So I'm going to assume it's going to be multiplicative. And a good way to find the relationship that's happening between our x and our y is to take the value, right? Remember, it starts with x, something happens, and then this is our outcome. So because our outcome's getting bigger, I'm going to take this number and divide it by 3 and see what we get. 28.5 divided by 3. Okay, 3 can go into 28.5 9 times. That's going to be 27. It's going to be 1. Decimal goes up, bring down the 5. 3 goes into 15 5 times. So I know this is a multiplicative rule of times 9.5. So, cool, not a problem. That means that the value of y is equal to 9.5 times the value of x. Cool, let's keep going. We're almost done. It's a pretty good one. Okay. Here we go. So, renting a canoe costs $5 per hour. Okay, that's important. Renting a canoe costs $5 per hour for each adult and $2.50 per hour for each child. One adult and two children rent a canoe. What's the equation? Okay, cool. It also says that shows the relationship between C, cost in dollars, and T, time in hours, okay? So if we're making this, okay, so your total cost in dollars is going to be your Y, and the time is going to be your X, okay? So the time is going to be independent. The time doesn't change. An hour is an hour, but your total cost is dependent on how long you rent this for, right? So they said that one adult, okay, one adult is $5. And then there's two kids. So kid 1 is $2.50 and kid 2 is $2.50. And so if I added all this up, I'm going to end up with a total of $10, right? For this one adult and these two kids to rent a canoe for this hour, okay? So for 1 hour, you would pay for this adult and two kids $10, right? So if we're turning this into an equation, we can say that the 10 your total cost is equal to $10 multiplied by the amount of time you're spending there, right? Your total cost, your Y, is equal to 10 times your 1 hour. All right, cool. So let's look at 13. It says, which equation best represents following situation? Okay, so here we have the width of a rectangle W is 6.5 inches. So I'm going to say W equals 6.5 inches. Cool. Less than the length of the rectangle L. Okay, so that's not bad. It's less than the length, right? So, okay, length minus 6.5 is equal to W. Not hard, right? 6.5 inches is less than the length. L minus 6.5 is equal my width. Okay, easy peasy. Cool, simple. Let's keep going. 14. Okay, perfect. So again, origin, right? Okay, so notice here though that we have build your XY table, right? Pretty easy, simple. Notice here that for our first one, right, it's in the middle. It's like a half, right? So we don't have to focus on that right now. We can just plot the whole numbers and then figure out what it is by dividing later. Okay, so if I plot my whole numbers here, okay, then I should have, let's see, 4 and 10. All right, perfect. So how do I find what 1x is worth? Well, I'll take my pair here and divide. I'll take my 5 and divide by my 2. That's going to give me 2. That's going to give me 4. That's going to give me 1. Decimal, 0. Bring it down, 0, 5. So that means for every 1, it's 2.5. Okay? So now I know that that's 1 and 2.5. If it's skip counting by 2.5s, then that's going to be 3 and 7.5. Cool. Now, write an equation. The value of y is equal to 2.5 times the value of x. All right? Super simple. All right, let's keep going, y'all. We're almost there. Okay, cool. 15. Awesome. So again, they want to know which equation represents the relationship. Okay, they only have 1, 0, which is weird. I don't know why. XY table real quick. Oh no, my brown's running out. Okay. I'm only gonna do 3 of these. Okay, 1 and 3, 2 and 6, 3 and 9. Okay. If you can tell, you should be able to see the pattern that this is going to be multiplicative and they're multiplying by 3. Okay, so I can say here that the value of y is equal to 3 times the value of x. All right, next one, 16. Here we go. Okay, so I don't necessarily have to build anything here, but it says here's our coordinate grid. Okay, quadrant 1, 2, 3, 4. They don't really care about that necessarily. I just like to reinforce it. Which point represents the ordered pair? So we have a fraction here, so we need to solve that. Let's go ahead and do it. 3 divided by 2, that's going to be 2. Oh wait, sorry. 2, 1, 2, 1, decimal, 0, bring it down, 0, 5. So our new ordered pair is really -2 and 1.5, and that's our x and that's our y. Cool, awesome. So now we have to plot it. Starting from our origin point, it wants us to go 2 units to the left, 1, 2, and then 1.5 units up, 1.5. Boom, our answer here is point R. All right. We have like 4 more and then we're done. All right. Let's look at 17. Which ordered pair describes a point that is located? Okay. Which ordered pair describes a point that is located 3 units to the right of the origin and 2 units below the x-axis? Okay, cool. 1, 2, 3. 1, 2. Plot my dot. All right, my x value is going to be 3, and my y value is going to be -2. Done. Easy. Super simple. Okay? So that one's done. That one's easy. Let's go to 18. Okay, so on a coordinate plane, point A is located at -5, 3 to get to point B. Okay, so to get to point B, move 8 units to the right, 6 units down, and 1 unit to the left. Okay, so we're starting at A. They want us to go 8 units to the right. Cool. 1, 2, 3, 4, 5, 6, 7, 8. 6 units down. 1, 2, 3, 4, 5, 6, and 1 unit to the left. 1. Here we go. Plot my dot. Ordered pair is going to be 2 is my x, and -3 is my y. Simple. Easy peasy, right? Last 2, guys. Okay, last 2. All right, here, I like to split it all the way down. That's just a me thing. You don't necessarily have to, but I like to do this. Okay, so cool, awesome. Now, tables below each represent a different rule. Okay, table 1 has a different rule than table 2. Which table represents a multiplicative rule, and what is the rule represented by that table? Okay, cool. So if I look at table 1, from 1 to 4, 4 to 16, 7 to 28, 10 to 4, I see here that they're multiplying by 4. Okay, look here, 1 to 9, 4 to 12, 7 to 15, 10 to 18. They're actually adding 8. So I don't really care about table 2. They want to know which table represents the multiplicative rule. So table 1, and what's that rule? Well, the rule is that y, or the value of y, is equal to 4 times the value of x. All right? Not too hard. Okay, last one, and then you're free. Okay, using the graph below, determine which line represents an additive relationship. Okay, so they want to say determine which line represents an additive relationship and which line represents a multiplicative relationship, and then write the relationship between x and y for both lines. Whew, okay, so seems like a lot. It's not that bad. I'm going to label this side as my solid line. I'm going to label this side as my dotted line. And I'm going to build a little x and y table for both, okay? Cool, real quick. Now, remember, when they intersect, okay, at a perpendicular line is when I'm counting that as an ordered pair. So for my solid line, I have 1 and 3. I have 2 and 6. I have 3 and 9. And I'll stop there because it's not really that important, right? Well, not necessarily keep going forward. We have 3 ordered pairs, so we can figure out what's happening from 1 to 3, from 2 to 6, from 3 to 9. I think this is my multiplicative relationship, and I think they're multiplying by 3. So I can say that the value of my y is equal to 3 times the value of my x. For my dotted line, let's use a different color. Yeah, we'll do this one. Okay, so for my dotted line, okay, I still have, let's see. Okay, so I still have 1 and 3, but then it goes from 2 to 4, and from 3 to 5. And so here I see it's an additive relationship that they're adding by 2. So I can write the equation that the value of y is equal to the value of x plus 2. And that's it. Hope this helps y'all.